Hello everyone, I am Ashwin from MSRIT CSC 8 SEM and my USN number is 1MS10CS144. The topic today I am presenting is Artificial Neural Networks. First of all, I would like to thank all the lecturers for letting me give this seminar. Now let us discuss some of the problems faced in today's world. Data is generated in our day-to-day life and this data is very huge, and our challenge is to understand, integrate, apply data to generate useful knowledge. The main key is always to collect data that has been buried in data itself. That is, we can collect different types of data that has been obtained from the information. System is taught how to perform a task instead of programming computational system to process those tasks. That is, system is made to learn those tasks instead of being programmed normally. To do this, we need an artificial intelligence system. Neural networks is one such case where a system is able to learn from the data continuously. A neural network can be defined as a reasoning model based on human brain. The brain consists of several interconnected nerve cells which basically performs information processing, and these units are called neurons. Each neuron is very simple in structure, but a cluster of such elements combined together constitutes tremendous processing power, and this structure is used for artificial neural networks. By use of multiple neurons together simultaneously, the brain can perform its function much faster than the fastest computers in today's world. Neural networks can learn things and are actually taught instead of being programmed. That is, they are taught how to perform certain tasks or certain things without being programmed as we do normally. Now let us take a look at the biological neural network. The diagram we see here has a neuron. Neuron basically consists of nerve cells and many other parts. Dendrites are the connecting parts in the neurons, and there are other parts such as axon, synapse, soma. Let us not get into the details of this. An artificial neural network consists of a number of very simple processors which are called as neurons, which are very similar to biological neurons in the brain. The artificial neural network is basically derived from the biological neural network, which we discussed earlier. The neurons are in turn connected to each other by weight links, which pass signals from one neuron to another. Neurons' outgoing connections help in transmitting the output signal. The outgoing connection in turn splits into a number of branches that transmit the same signal. The incoming connections of the neurons terminate the outgoing branches in the network. Let us take a look at the diagram of this. Artificial neural network architecture. It basically consists of three layers: input layer, middle layer, and the output layer. The input signals are passed through the input layer first, and then it is processed in the middle layer, and the output signals are obtained in the output layer, which are then passed on. Artificial neural network is a machine learning approach. Artificial neural network basically deals with machine learning and many of its concepts. Basically, machine learning helps artificial neural networks to function efficiently. The information about learning task is given in the form of examples called training examples. We will discuss about these examples later in our presentation. Artificial neural networks is specified as follows: neuron model, architecture, learning algorithm. Neuron model. It gives information processing unit of the neural network. Basically, all the information is processed in the neuron model, and different types of information is classified and it is then used for processing. Architecture. It consists of a set of neurons and links connecting together all the neurons. Each link is assigned some weight, and the architecture basically depends on the weight of the links. Learning algorithm. There are different types of algorithms used for learning, and some of them are discussed later in our presentation. Learning algorithms are used for training the neural network by modifying the weights in order to model a particular learning task correctly on the training examples. The aim is to obtain a neural network that is trained and generalizes well, and the neural network must perform most efficiently so that we get the desired results. Neuron. The neuron is the basic information processing unit of the neural network. It consists of a set of links describing the neuron inputs with weights W1, W2, an adder function or a linear combiner for computing the weight sum of inputs. The equation for computing the weight sum of inputs is given as below. And then activation function. Phi is used for limiting the amplitude of the neuron's output. And in this equation, B denotes the bias. As we see in the neuron diagram, x1, x2, x3, xm are the input values, w1, w2, w3, wm are the weights of the neurons, and B is the bias, and all the weights and the input values are given to the summing function, and activation function is used to produce an output. Neural network architectures. There are three different classes of neural network architectures: single layer feed forward, multi-layer feed forward, and recurrent. The architecture of neural network is linked with the learning algorithm used to train. Single layer feed forward network. There are two layers. One is input layer of the source nodes and output layer of neurons, as shown in the figure. Multi-layer feed-forward network. Feed-forward neural network is a more general network architecture where there are hidden layers between input and output layers. Hidden nodes do not directly receive inputs nor send outputs to the external environment. Feed-forward neural networks overcome the limitations of single-layer neural network. Usually, multi-layer feed-forward neural network is used instead of single-layer feed-forward network. They can handle non-linearly separable learning tasks. As shown in the diagram, there is an input layer, there is an hidden layer in between input and output layer, and there is an output layer. Input layer takes a number of inputs, output layers gives a number of outputs, and the hidden layer processes most of the information. Recurrent network. Feed-forward neural network is acyclic where data passes from input to output nodes and not vice versa. Once feed-forward is trained, its state is fixed, which acts as a disadvantage and does not alter as new data is presented to it. It does not have memory. These are main disadvantages of feed-forward neural network, which resulted in the discovery of recurrent network. Now let us discuss about recurrent network. Recurrent network can have connections that go backward from output to input nodes and models dynamic systems. Recurrent networks are usually designed on the basis of recursive functions that are used in C or C++ or any other programming language. The basic concepts are the same except for the fact that we use neurons or the neural networks in our architecture. Recurrent network is useful in solving problems where the solution depends on not just the current inputs but all the previous inputs. Basically, the output is fed back to the input and the input provides us an output. This task is performed until all the desired output values are obtained. There are many applications of recurrent networks. Some of them are predicting stock market price and weather forecast. Let us take a look at the diagram of recurrent network architecture. Recurrent network with hidden neuron. Unique delay operator D is used to model a dynamic system. D is the unit delay operator as shown in the figure, and there are input nodes, there are hidden nodes, and there are output nodes, and the output is generally fed back to the input until the desired output value is obtained. We can see all of these functions in this diagram. Learning and training. During the learning phase, a recurrent network feeds its input through the network, including feeding data back from the outputs to inputs. Process is repeated until the values of the outputs do not change. Recurrent networks can be trained by using backpropagation algorithm. In this method, that is backpropagation algorithm method, at each step the activation of the output is compared with the desired activation and errors are propagated back through the network. Once the training process is completed, the network becomes capable of performing a set sequence of actions, and many desired actions and tasks are performed using this network. Now let me ask you a question. Can a single neuron learn a task? Of course it can. In 1958, Frank Rosenblatt introduced a training algorithm that provided the first procedure for training a simple artificial neural network. A simple artificial neural network, which is also called as a perceptron. The perceptron is the simplest form of neural network. It consists of single neuron with adjustable synaptic weights and a harder limit. Weights are similar to the weights discussed earlier in the neural networks. Single layer 2 input perceptron. There are two inputs in this perceptron, and there are two weights W1 and W2. X1 and X2 makes the two inputs, and there is a linear combiner indicated by sigma in this diagram, and there is a hard limiter, and there is a threshold which is denoted by theta. All these are combined to give a output Y. There are many different problems that are solved by artificial neural networks. Some of them are mathematical modeling, classification, clustering, forecasting, vector quantization, control, optimization. Now let us discuss some of these problems. Mathematical modeling. Modeling often mathematical relationships between two sets of data are unknown analytically. Data is often noisy. Classification. Assignment of objects to specific class. There are different types of objects that can be encountered in day-to-day life, and these objects should be classified to perform certain tasks. This classification is solved by artificial neural networks and performs efficiently. Given a database of objects and classes of those objects, the data must be classified. Clustering. Grouping together objects of similar kind. Forecasting. Prediction of future events based on history. Trends and regularities often masked by noise. Some of the examples of forecasting is weather forecasting, which is the best example that can be solved by artificial neural networks. Vector quantization. Object space divided into several connected regions. Objects classified based on proximity to regions. Closest region or the node is declared as the winner. Control. Manufacturing, robotic and industrial machines have complex relationships between input and output, and this control is provided by neural networks. Optimization. Requirement to improve systems performance or cost are subjected to constraints, and this sort of optimization can be solved using neural networks. There are many different applications of artificial neural networks. Gotcha, biomedical signal processing, biometric identification, system reliability, business and target tracking. Let us discuss some of these applications. Gotcha. Current surveillance and reconnaissance systems structured to observe huge areas attempt to detect movement of hostile forces. Use of images to locate an explosion, run data back in time to identify the vehicle, lock onto the vehicle, and backtrack to locate significant portions of path, assembly areas, passenger pickups, arming site, and any other spot related to the vehicle at the time of the accident. Biomedical signal processing and biometric identification. There are many different applications developed in this area. Some of them are instant physician developed using neural networks. Network is presented with a set of symptoms, medical records, and the output is the best diagnosis and treatment. System control and reliability. Backing up a truck to loading a dock is very difficult problem for a novice and easy for an experienced driver. These sort of difficulties are often experienced in industries. Very difficult problem mathematically, but it can be trained. That is, a neural network can be trained to efficiently load and unload a truck. This saves a lot of time and lot of manpower. Automobile airbags can undo serious damage to the passengers using neural networks. System reliability continuously assessed and failure prevented by correct interpretation of data from accelerometers. Business mortgage risk assessment. Risk risk assessment reduces delinquency rates. Inputs include years of employment of dependents, property information, income, loan to value ratio. Automated target tracking and recognition. Algorithms for automated target tracking and recognition of targets have been recently identified by National Critical Technologies Panel as of critical importance. Automated target recognition, localization, and tracking in the presence of artificial neural networks is an important signal processing problem. Now let us take a look at a practical and a real life application of artificial neural networks. The example we are discussing is customer loan approval. Many stores are now offering their customers the possibility of applying for a loan directly at the store so that you can buy the product and you can also get the loan sanctioned then and there itself. So they can proceed with the purchase of relatively expensive items without having to put the entire capital all at once. The loan applications are filled out at the store and the customer only deals with the store clerks for the entire process. The store, however, relies on a financial company that handles such loans, evaluates the applications, provides the funds, and handles the credit recovery process. When a client defaults on repayment schedule, ANN application to loan approval. Each application has 15 variables that included the number of members of household with an income, the amount of loan requested, whether or not the applicant had a phone, and many others. Let us take a look at that in the next slide. The input variables and the variable values. There are 15 different input variables and most of the variable values are numerical or an integer value. The input variables are the number of relatives with job, telephone number, real estate, residency, seniority, other loans, repayment method, job type, job seniority, net monthly earnings, collateral, loan type, amount of loan, amount of installment, duration of loan. Computed output variable. Repayment probability is decided from a scale of 0 to 100. Desired output variable. Real result of grant of loan 0 if the payment is irregular, 100 if payment is on schedule. Some of these variables were numerical. For each record, a single variable indicated whether the loan reached was extinguished without any problem or with some problem. In analysis, the bank classified loans with Z is equal to 0 as bad loans. In provided data, only about 6% of the loans were classified as bad. Thus, any artificial neural networks that classifies loan from a similar population ought to make errors in a percentage that is substantially lower than 6% to be of any use. One of the practical example using which the previous slides were discussed was, out of 1000 available records, 400 were randomly selected as training set for configuration of the artificial neural networks. That is, training set is used for the configuration of the network. The remaining 600 cases were supplied to the configured artificial neural network so that the computed output could be compared with the real value of the variable, which is denoted by Z. The research team selected a network with 10 hidden nodes as the one that provided the most promising performance. The number of iterations was set to 20,000 to allow a sufficient degree of learning without loss of performance in generalization capability. The single output of our network turned out to be in the range of -30 to +130, whereas the corresponding real output value was limited from Z is equal to 0 to Z is equal to 100. A negative value of the output would indicate a very bad loan, which results in disapproval of the loan. A 30% tolerance was used on the output so that the loan would be classified as good if the artificial neural network computed a value above 70 and bad if their output was less than 30. Loans that fell in the range of 30 to 70 were classified as unclassified. This specific neural network was then supplied with the remaining 600 cases of testing set. The set contained 38 cases that had been classified as bad, that is, Z is equal to 0, while the remaining 562 cases have been repaid on schedule. Clearly, the neural network separates the given cases into two non-overlapping bands. The ones, that is, the good ones near the top and the bad ones near the bottom. No loan was left unclassified. So in this case, there would have been no cases requiring additional human intervention. Let us take a look at the above discussed example in the graphical form in the next slide. Good loan area, that is classified from 70 to 90, and unclassified area is given on the graph scale from 30 to 70, and the bad loan area is given on the graph scale from 10 to 30. We can see that the good loan area has more number of people and the bad loan area has less number of people, and there are no people in the unclassified area. So this concludes our discussion on the topic artificial neural networks. Thank you for hearing me out for this seminar. Please contact me on the email ID winash77@gmail.com, winash77@gmail.com. Thank you.